Tornadoes are very complex in the way they form, and they are still being very widely researched to better understand exactly when and how they form. But what we know now is that they are a rotating column of air. Now, this column of air is part of a thunderstorm, and it's usually starting off rolling horizontally. Now, think of this column of air as a roll of wrapping paper rolling along the floor. And then we get in something called wind shear, where there is different wind speeds and directions with height. It might be slower at the near the surface and then get a little faster and come from a different direction higher up. And then eventually that rotating column of air will tilt because of that difference in winds. Now again, tornadoes do form as part of thunderstorms, and what we do know of them is that you do need some instability for a tornado to form. That is our warm air at the surface, warm and moist air. And then higher up in the atmosphere, you have cool and drier air. This creates an unstable atmosphere. We also, again, need that wind shear to help that rotating column of air. And now think of this as well. An updraft in a thunderstorm is needed. It is an essential part of a thunderstorm. If you have your thunderstorm here, and then your updraft is the air that is going into the thunderstorm and helping fuel that. And the wind shear will help strengthen that updraft and help that updraft to potentially start rotating, and then could lead to the formation of a tornado. But you need that rotating updraft in a thunderstorm for there to be a possibility of a tornado. So looking at radar is one of the best ways for us to see if a storm is producing a tornado or might produce a tornado. Supercell has a very specific look to them on radar. This is the Gaylord tornado from 2022. It is a textbook image of a supercell on radar. And now, not all supercells are going to look textbook, and that's where good analysis comes in of like knowing the parts of the storm and analyzing wind directions and all that information that's coming in actively as meteorologists are watching that radar information. Because sometimes tornadoes won't be in a supercell, they'll be a part of a just line of storms that we will typically call a squall line. Sometimes they will be embedded within those lines and won't necessarily take on a supercell structure like this. So in this, though, we have the severe thunderstorm warning in yellow. That polygon shows that this storm is dangerous, and then our tornado warning in red there around that. And you can see the tornado warning encompasses this part of the storm down at the bottom. This is what we call the hook. It's on the rear part of the storm, and that hook is created by those winds actively rotating around. That is where our rotation is occurring, and this is where that tornado was happening. So to some extent, all supercells are going to have this structure. This is our main portion of that supercell. The winds are blowing it that way. That's going to be your biggest part of the cloud structure. Could have some hail in this region, and The rear flank, it's called, is where you're typically going to see those winds rotating. That's where it's going to hook around. And they won't always be as defined as this, but they are going to have that structure. Tornadoes are rated based on damage by certain wind speeds. So when meteorologists and other experts go out to survey damage by a tornado, they determine the wind speeds of that tornado based on the damage that was done by the tornado. They're looking at an array of items that are damaged, not just one thing, to then kind of summarize that up. And based on the damage that they see, then they can determine the wind speeds within the range of our original tornado rating scale here. So the higher the wind speeds, the more damage that can occur. So let's look at tornadoes specifically in Michigan. We can look over the roughly 30 years. Michigan has seen 13 tornadoes on average each year. So some years we've gotten more, some years we've gotten less. And typically the months that we see the highest risk for these tornadoes here in Michigan is April through September. Now, if we slide over, we have seen a tornado, at least one tornado each month except January and December. And in this graph, you'll notice that the majority of tornadoes are in the April through September range for us here in Michigan. So let's sum all of this up. Number one thing is that tornadoes can happen in Michigan. They have been reported in the Upper Peninsula, here in the Central and Northern Lower Peninsula, and downstate in the Southern Lower Peninsula. Our most recent strong tornado here in the Northern Lower was in 2022. That was an EF3 in Gaylord. That was on the stronger side. So to get tornadoes, we need that instability and wind shear to help create the rotating column of air within a thunderstorm. They can happen in a supercell thunderstorm or in squall lines, and they are still being widely researched because while we have some of an idea of how they can form, sometimes we have these ingredients and they won't form. So knowing when they will happen, how strong they could be, is still being understood. I want to thank you for listening this far into the video. If you have, I hope that you learned something new in this video about tornadoes. You can always ask me more questions down in the comments if there is something you would like more clarification on.